Let's now have a look at the sum of our other special type of sequence, the geometric one. So sum to n would be all of the terms added together, so a plus ar squared, all the way up to the last term, ar to the power of n minus 1. I'm going to rewrite it, but multiply every term by r. And I'm going to line up the like terms. So a times r, ar times r, ar squared. It now means the last term is ar to the power of n. But if I subtract these, then all of these terms, the ar minus ar squared minus ar squared, and so on, will cancel out, leaving me with just the last term of the bottom equation minus the first term of the top equation. So r minus 1 sum to n is ar to the n minus a. Divide everything by r minus 1, and we come up with a formula for the sum to n terms. Now, we use this formula if the size of the ratio, so just interested in the magnitude, not worried about plus or minus, is greater than 1. If it's less than 1, then we tend to go 1 minus r to the power of n over 1 minus r. It actually doesn't really matter which one you use. The main reason we do it is so that we end up with a positive number in the denominator if we can. So let's do some examples. First 10 of this particular series, 2, 6, 18. Well, first term is 2. The common ratio, well, we're multiplying by 3 each time, and we said 10 terms. So sum to 10, I'll use the r minus 1 formula because our ratio is bigger than 1. So I get a, which is 2, r to the power of n, 3 to the power of 10, minus 1 over r minus 1, 3 minus 1. And that all tidies up to be 59,048. Of course, we could have sigma notation, same as we did with the arithmetic ones. But be careful here. You'll notice the first term is actually n equals 3, not n equals 1. So let's extract the information. Our first term, n equals 3, will be 6 times a half squared, and that ends up being 3 on 2. The common ratio is a half. How do I know that? Well, look at the general term. The general term is still ar to the n minus 1, so the ratio is a half. And the number of terms, 8 minus 3 is 5, but it's inclusive, so add 1, we get 6. Subbing that into our formula, this time I'm using the 1 minus r formula because the ratio is less than 1. So subbing into that, I get a, 3 on 2, 1 minus r to the power of n, so 1 minus a half to the power of 6, all over 1 minus a half. And that all tidies up, and eventually we get 189 on 64. Personally, I work out the half to the power of 6 first, subtract that from the 1. All right, so just a quick bit of theory there for today. Exercise 1G